Since then, for me, I know they feel box. All for something, I just want to give it up. Some, I see why you love. I see why you love. What's I do? I see why you love. Oh, na, na. Love, come on, baby. Even I love, come on, ask for you. Why can't you come, baby? You become my favorite. Now I love more than get down. I really see you, baby. Na, na. So you say now you the one I go love forever. Show me the place you need me, girl. I go run to you wherever. Ease your love and let me better. Know you wanna let me say that you gonna be my baby, that you gonna be my baby. Baby, like that I will. You make me love my teeth. You wanna drop my season. Baby, baby, at the end, everything check up. No more check out, no more plenty. Wake up in the morning, send me. Check up in the morning, send me. Baby, I'm happy to come on, baby. I love to come on, ask you money. Why can't you come, baby? It's me now. You become my favorite. Now I love you, I don't get down. I really see you, baby. Yes. I want to do that like. Welcome. No time to waste. We're starting immediately. Welcome. As you're coming in, drop your comment. Let's start. Drop a comment. Let's start. Welcome. No time to waste. We're starting straight away. No time to waste. No time to waste. Someone said, long time, sir. How are you? I'm fine. Thank you. I'm fine. You're welcome. You're welcome. You're welcome. Welcome, everybody. Welcome, everybody. Good to see you. Good to see you. Long time no see. So, yesterday we had chemistry live class, right? Today is physics. Welcome. Yes. Clinton said I'm here. Yes. Peculiar said yes. Good evening, sir. Divine, she's over, sir. Please don't the class be ending. Whenever start, don't the end. How far now? Class are not that you want to end. When will the class be ending? No, we'll end. We'll end. Let's start. Let us start. Today is relation and function. Oh, sir, when we learn limits and continuity. Today we want to learn relation and function. After relation and function, then the limits and continuity. So I really missed you. Yes, we missed you too. Although it's not been long. It's not like we did class last week, right? That day I was teaching myself. Welcome, Sandra. Yes, so you're coming in, please drop hit the like button. Hit the like button. Let's start. You're all welcome. 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 No time to waste. Yes. No time to waste. I believe others will join us and then they will kick off. No time to waste today. I've sent the link everywhere, so no time to waste. No time to waste. Today, I want to look at relation and function. Today is relation and function. I hope we're all active. Hope you can hear me. You can hear me from the board, right? You can all hear me from the board, right? Please, you're coming in. Hit the like button. No time to waste. We're starting immediately already. Hit the like button. You're not subscribed to our channel yet, please hit the subscribe button as well so that when we come live, you can easily know. Welcome, everybody. If you're not subscribed to our channel, hit the subscribe button, hit the like button. I'm going to the board to start. Yes.
Before I start, can you hear me from the board? If you can hear me from the board. I hope you can all hear me from the board. So without wasting much time, let's start with a relation. What is a relation? What is a relation? A relation, write down. A relation. A relation is a rule or principle. A relation is a rule or principle that assigns elements. A relation is a rule or principle that assigns elements of one set to another. A relation is a rule or principle that assigns elements of one set to another. A relation is a rule or principle that assigns elements of one set to another. I hope we are following. Hope we are following, please. I hope you can hear me well. Please drop a comment. If you can hear me, let me know, please. Let me not be teaching myself. Please drop a comment if you can hear me well. Drop a comment if you can hear me well, please. So I can go back to the board. Drop a comment if you can hear me well. Yes, Covenant said yes. Divine said yes. Good, good. Drop a comment. Let's go now. Relation is a principle, a rule or principle that assigns elements of one set to another. So basically, it's a rule that guides interaction between two sets. A relation is a rule that guides interaction between two sets. Is a rule. You can say that shows the interaction between two sets. Is a rule that shows the interaction between two sets. A relation shows the interaction between two sets. Are we together? What's the symbol for relations? R. R is the symbol for relation. Why is this topic very important? It's important because it's in both your Math 110 and 120. So if I'm covering this topic now, please, it means you have covered the topic for Math 110 and 120. It means you have covered the topic for Math 110 and 120. So we use R to represent a relation. So if we have two sets, for example, set A and set B, the relation between A and B, we now use R to represent it. That means A is related to B in what way? A is related to B in what way? Now, for two sets to be related to each other, there must be a binding factor or another. So every relation has a binding factor or another. Please take note. A binding factor or another. Binding what? Factor or order of the relation. The binding factor or the order of the relation helps us to establish the relationship between the two sets. So if set A and set B are to relate together, there must be something that is making two of them relate together. What is the binding factor? What's the common ground that A and B is relating with? Let me explain further. Let us say you have a set A. Set A is 1, 2, 3, 4. And set B is 1, 4, 9, 16. Remember, for a relation to exist, there must be two sets at least. Because a relation is a guide or a principle that shows the interaction between two sets. It's a principle that shows the interaction between two sets. So set A is 1, 2, 3, 4. Set B is 1, 4, 9, 16. And you have to form a relation. Form a relation whereby A is equal to the square root of B. So you have to form a relation whereby A is equal to the square root of B. What does this mean? It means that in a relation, the relation you are going to form, the members of A, each member of A must be paired with its square in B. Now, something I forgot to tell you. How are relations? How is a relation made? A relation is made, exists in pairs. Please take note. Relations exist in what? Pairs. That's one important fact you should know. Relations exist in what? Pairs. Yes. Relation exists in pairs. So a relation cannot just stand on its own. It exists in pairs. Now, why does it exist in pairs? Because relation is an interaction between two sets. So there must be a member of this set that is interacting with a member of this other set to form a pair. There's a member of this set that interacts with a member of this set to form a pair. For example, they say find a relation such that A is what? Is a what? Is a square root of B. So the relation for this particular binding factor is going to be 1, 1, 2, 4, 3, 9, 4, 16. Class, this is the relation. You can see they're existing in pairs. And in the pair, because the relation said A should always tend to the square root of B, meaning that for every member of A, it should be the square root of what? B. Yes. You notice 1 is the square root of 1, 2 is the square root of 4, 3 is the square root of 9, 4 is the square root of 16. So the binding factor, remember I told you every relation has a binding factor. Every relation has a binding what? Factor or an order. So the binding factor of these two sets is that A is the square root of B. What binds A to B is that for every member of A is the square root of what? Member of B. So for every member of A you B, you must make sure that its square root is found here. So you can see 1 is the square root of 1, 2 is the square root of 4, 3 is the square root of 9, 4 is the square root of what? 16. We have just formed the relation based on the order. So this A square root of B is called the what? Order of the relation. Another name for order is binding factor. Another name for order is what? Binding factor. I hope we are still following. I hope we're still following the class. How many are we now? We're at 33. That's 3. Well done, well done, well done. Same class, but you're still here. Well done, class. Good, good, good. I hope we are following the class. I hope we are following the class. Class. Let's take a question. Let's take a question quickly. Given the sets, example now. Given the sets, A equals 1, 2, 3, 4, 5, 6, and B equals 1, 2, 3, 4, 5, 6, 7, 8. Find the elements of the relation R from A to B, defined as ARB if B is equal to 2A plus 1. If B equals to 2A plus 1 class, this if B equals to 2A plus 1 is the binding factor or the order of the relation. Class, nobody will ask you to establish a relation without giving you the binding factor or the other. Because two elements cannot relate until they have a common ground, the binding factor, one other. Please take note. So for A to relate to B, B must be equal to 2A plus 1. Class, and take note, they said ARB. Class, anytime they say find the relation ARB, it means that the members of A must be mentioned first in each pair. Don't forget, class, that for a relation exists in pairs. Relation exists in what? Pairs. It's important that you know that the members of A should come first because this is A relating to B. If the question said B relating to A, then the members of B should come first before A. But if the question said A relating to B, the members of A should come first before B. So we're going to first test what members of A fit this equation. What members of A fit this what? Equation. Let's start with the first member of A, which is 1. If you put 1 into this equation, you're going to have 2 times 1 plus 1. What is 2 times 1 is 2. 2 plus 1 is 3. So when A is 1, B is 3. Do we have 3 in B? Yes, there exists. 3 exists in B. So we have gotten our first pair. But when we put 1 into the binding factor, A as 1, we got B as 3, and 3 exists here. So our first pairing is 1, 3. Note I mentioned the A member before the B member. Now let's try 2. Come back to the binding factor, put 2 into this equation. 2 times 2 is 4. 4 plus 1 is 5. Do we have 5 here? Yes. So 2 to 5, our second pairing. So a relation can have more than one pair, can have 2 pairs, can have 3 pairs, can have 4 pairs. Let's put 3 into this equation. 2 times 3, 6. 6 plus 1, 7. 7 exists. So when we put 3 into the binding factors, we have 7. Let's put 4. 2 times 4, 8. 8 plus 1, 9. 9 does not exist in B. Therefore, class, this is the relation. This is your final answer. 1, 3, 2, 5, 3, 7. This is the answer to this question, class. Please, I hope we are following. I hope we are following. Please drop a comment. Let me be sure that we are following. Drop a comment. Let me be sure that we are following. If you're also lost, let me know. If you want me to come again, let me know. Whatever you need, let me know. I'm checking your comments now. I'm seeing your comments. Okay, Victor said active. Fabian said active. Alex Otumi said yes, sir. Okay, Ejuku Francisca said please come again, sir. Okay, I've seen my first come again today. Let me come again. Let me just come again just to be clear. The question said, given the sets A equals 1, 2, 3, 4, 5, 6, and B equals 1, 2, 3, 4, 5, 6, 7, 8. Find the elements of the relation R from A, note, from A to B, meaning that you have to pick from A first before you get to B. And if the question said from B to A, that means you take members of B first before A. If the question said from B to A, then members of B first should be mentioned before what? A. But the question said from A to B, so A should come first before B. Class, later on I'll tell you why the person that comes first in the pairing matters a lot. We'll get there. Now let's say find the element of the relation R from A to B. Find the element of the relation R from A to B, defined as ARB. If, class, if, this is very important. Class, they ask to determine the relation, they don't say if. Class, you may also determine the relation. Why? Because this if gives you the binding factor. What brings the two sets together? How are you going to know who is going to pair to who here? How are we going to know? Until we have what? A binding factor. I told you earlier that every relation between two sets, there's always a binding factor. For every relation between two sets, there's always a binding factor. So class, relation is simply a topic under sets. Relation is the interaction between two sets. Class, once two members of two sets interact, a relation is established. Once members of two sets interact, a relation is what? Established. But members of two sets cannot interact until a binding factor is first known. Because there must be a common ground. Why are these two sets interacting? There must be a binding factor. There must be a common ground and order. So every interaction between two sets comes with a binding factor, one order. Now, the binding factor of this set A and B is that for B, for every member of B, it is 2A plus 1. B is 2A plus 1. So what are we going to do? We're going to test what members of A fit this criteria. We're going to pick the first member of A, 1. Put him into it. Anywhere you see A, put 1. And find out what came out. What came out is what? 3. So it means that B is 3. When A is 1, B is 3. You now go back to set B. Does 3 exist in set B? Yes, it exists. Therefore, we've gotten our first relation. So when A was 1, B was 3. So 1, 3. Don't forget, relations are arranged in pairs. Relations are arranged in what? Pairs. First pair is established. The second pair class, we try to put 2, A has 2 into this equation 2 times. Remember, this is the binding factor. So this is where we always come to test the interaction between the two sets. The binding factor is where you always go to test the interaction between the two sets. So we'll take 2. We already tried 1. We saw that 1 existed, right? 1 put 1, we got 3. So 1, 3, we got in our first pair. So when you're trying to establish a relation, you're trying to establish pairs. All together, anything you're trying to establish a relation, you're simply trying to establish what? Pairs between two sets. So when A was 1, B was 3. So 1, 3. When we put 2 into this equation, 2 times 2 is 4. 4 plus 1 is 5. Does 5 exist in B? Yes. So when A is 2, B is 5. So 2, 5. What's in our second pair? Put A as 3 into this expression. 2 times 3 is 6. 6 plus 1, 7. So when A is 3, B is 7. Is there 7 inside B? Yes. So I've gotten our top pair, 3, 7, our top pair. When A is 4, 2 times 4 is 8. 8 plus 1 is 9. There's no 9 in B. Therefore, this can only be our relation. I did not need to go further to test 5 and 6. Because this stops at 8. If you put 5 into this expression, you get more than 8. If you put 6 into the expression, you get more than 8. So our relation is 1, 3, 2, 5, 3, 7. Please, this is better now. It is better. Drop a comment in the comment section. Make sure you're not sleeping. Put your phone on DND so that you will not be distracted. This is mathematics. You can't afford to be on TikTok and you're learning. Put your phone on DND. If you understand it, please drop a comment. Drop a comment. Let me see. Drop a comment. Good, 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 good. AJ Kuna said, I understand. Thank you. I'm happy that you replied. Yes, you asked the question, I should come again, and you said you understand. Thank you for that. Some people will say come again, but after you've done it, they will not even do as if they sent you. Thank you, Francisca, for recognizing that yes, you came again and you understood very well. So everybody understand. Are you ready for your classwork? Are you ready for your classwork? Okay, classwork. Are you ready? Given the sets, C equals, given the set C equals 1, 3, 4, 8, and D equals 2, 5, 7, 9. Find the elements of the relation R from C to D if from C to what? D. If D is greater than C. If D is greater than what? C. Class, this is your classwork. This is your class. Remember, example is for teacher, classwork is for students. Example is for teacher, classwork is for students. Class, this is your classwork. Go ahead. I want you to find the relation. Given the set 1, 3, 4, 8. Hope you're writing material. Hope you're writing material. Given the set 1, 3, 4, 8. C is 1, 3, 4, 8. D is 2, 5, 7, 9. Find the elements of the relation R from C to D. If D is greater than C, I hope we're still there. This is a class for go ahead and solve. I'm giving you just 30 seconds. I want to see your answer. Go ahead and solve. Go ahead and solve. Go ahead and solve. Go ahead and solve, class. Go ahead and solve. I hope we are still there. I hope we are still there, please. Let me be sure this group is still active. I hope we are still there. Good, 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 good. Go ahead and solve. Go ahead and solve. Given the set C equals 1, 3, 4, 8 and D equals 2, 5, 7, 9, find elements of the relation R from C to D if D is greater than C. Again, look, Fabian, you got 1, 2, 3, 5, 4, 7, 8, 9. Okay, well done. You tried. Alex wrote to me, said you are done. Where's the answer? Where's your answer? If you are done, where's your answer? Please make sure you are involved. Make sure you are involved. Some of you are missing it. There's something, there's a trap you are falling for. There's a trap I set for you, you are falling for it. Where's your answer? Tennis chalk said 1, 2, 3, 5, 4, 7, 8, 9. There's something you are not doing. 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 I still solving. I still solving. Hope you have not slept. Oh. Hope you guys have not slept. Oh. Make sure you are solving. Make sure you are solving. Blessing on your yes. Well done. Don't be that still interacting with the class. Well done. Well done. 2, 1, 5, 3, 7, 4, 9, 8. Marianne, Ijoma 3, 5, 4, 7, 8, 9. Okay, let me go and do the correction. 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 Class, given the set C equals 1, 3, 4, 8 and D equals 2, 5, 7, 9, find the elements of the relation R from C to D if D is greater than C. Class, the relation R, the dividing factor is that D must be greater than C. So we're going to pick, and who should we mention first? From C to D. So start with 1. So our first pair is 1. What members of D is greater than 1? 2 is greater than 1, so that's 1, 2. But that's not all. That's just not we made a mistake. It's not only 2 that's greater than 1. 5 is also greater than 1, so that is 1, 5. 7 is greater than 1, 1, 7. 9 is greater than 1. 1, 9. Now go to 3. What members of D is greater than 3? 5. So 3, 5. Because 5 is greater than 3, right? 3, 7. 3, 9. 3 is done. Let's go to 4. What members of D is greater than 4? 5, 7, and 9, right? So that's 4, 5, 4, 7, 4, 9. Now let's go to 8. What members of D is greater than 8? Only 9. And 8, 9. Class, this is the relation. Who got this? Anybody get this answer? This is the relation. This is the relation. This is the relation. Did anybody get this answer? Please drop your comment if you understand. Drop your comment. Drop your comment. Let me see the reactive. Drop your comment. Drop your comments. Good, good. Michael Obri say understood. Yes, good, 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 good. Alex wrote to me said no. It's very straightforward. What we did, they said for every if D is greater than C, plus every you measure every member of D that is greater than C. So I pick the first member of C, which is 1. What member of D is greater than C? If you look at the first member of C, 1, you see that 2, 5, 7, and 9 are all greater than 1, right? So you must mention the pairs for all those relations. So that's 1, 2, 1, 5, 1, 7, 1, 9. Someone said, well, I've never gotten it even in 100 tries. Well understood now. Good, good. It's good to hear that. It's good to hear that. You see why classes like this are very, very important. You see, in the exam honor, you might never have known that this is what it means. So this 1, 2, 1, 5, 1, 7, 1, 9, 3, 5, 3, 7, 3, 9, 4, 5, 4, 7, 4, 9, 8, 9. Those are the relations. Let's go to the next topic now. Let's go to the next topic. Now write down source set and codomain. Let us look at source set and codomain. Source set. Source set and codomain. Now let's start with source set. Source set. No, the source set is a set from which the first entries are taken. A set from which the first entries are taken. Source set is a set from which the first entries are taken. It's called a source set. A set from which the first entries are taken. The first entries are taken. Now, what of codomain? Codomain is also referred to as target set. Target set. Codomain is referred to as target set. The codomain is a set of elements. A set of elements being mapped to, set of elements being mapped to is called the codomain or target set. Set of elements being mapped to is called the what? Codomain or target set. Class, cut the long story short. These examples we're doing recently, when we gave you set A and set B. If you notice, the set of A always tended to set B. The source set is always targeting the what? The codomain, which is the what? Target set. That is a set of elements being mapped to. The source set is where you first pick from. That's what's called the first entries. When you are arranging a relation, the first pair, where you pick your first pair from, the set of elements you pick your first pair from is known as the source set. So in every relation, remember relation exists in pairings, right? Relation exists in pairings. In every relation, the first entry of the pairing is gotten from the source set, while the second entry of the pairing is gotten from the what? Codomain of target sets. The first entry of the pairing in every pairing in relation 1, 2, 1, 3, 1, 4. That one, that first person mentioned, is usually obtained from the source set. And the second member of the pairing is obtained from the target sets. Now let's write down domain. Let's write down domain. Domain. Let's write down domain. Domain of a relation. Domain of a relation. The domain of relation is the set of values for which the relation is defined. Domain of relation is the set of values for which the relation is defined. Domain is a what? Set of values for which the relation is defined. It is a collection of all the first entries. The domain is a collection of all the first entries. It is the collection of all the first entries. It is the collection of all the first entries. Are we still together, class? Are we still together? Are we still together, class? Let me see your comment if we are together. Make sure you're not sleeping. Oh, if sleep is catching you, take water and put in your eyes. Okay, good. Everybody saying yes, sir. Good. Those of you commenting, well done. Wisdom, Caleb, Frank, well done. Those commenting, well done. Christian, well done. Victor, active. That's good. I like it. I like this. Caleb, we're together. Frank, Victor, good to see you. Yes, good. Well done. This is good. Well done, class. Okay, let's continue. Yes, stay woke, don't sleep. Yes, no darling. Yes. Now, class, we've just defined domain now. Let us now define range. Class, what's the difference between domain and source set? Please take notes before we go to range. Let me drop one more point on domain. Write down. Let me drop one more point on domain. Domain can also be defined as a collection of all elements. Domain can also be defined as a collection of all elements in the source set that are paired with elements in the target set. Domain can also be defined as a collection of all elements in the source sets that are paired with elements in the target set. Domain can also be defined as what? A collection of all what? Elements in the source set that are paired with elements in the target set. Who remembers the last question we did? If you notice the last question we did, I gave you C and D. Then I gave you 1, 2, 3, 4, 5, something like this, right? And then I gave you 3 also. 3, 5, 7, 8, and 9. If you notice very well, when we formed our relation, it was not all members of C that appeared in our relation. Also, it was not all members of D that appeared in our relation. What was our final answer? 1, 3. No, not this one. Not this question. Not this question. It wasn't. Let me give you the former question that we said. What is that question? A to B. Yes, A to B. So there was one we gave A to B that we said. What was that question again? There's a point I'm trying to make. Please let me check that question quickly. Yes, the one we said A is 1, 2, 3, 4, 5, 6, 7, 8. And B is, oh sorry, this is B. And A is 1, 2, 3, 4, 5, 6. This A and this B. The first question we did today. A is 1, 2, 3, 4, 5, 6. And B is 1, 2, 3, 4, 5, 6, 7, 8. And we said the order is B equals to what? 2A plus 1. Remember? Our final relation was just 3 answers. Who remembers? We put 1 into the expression, we got 3. So 1, 3. We put 2 into the expression, we got 2 times 2. 4, 4 plus 1, 5. So we got 2, 5. So 1 paired to 3. 2 paired to 5. 3. 2 times 3 is 6. 6 plus 1, 7. So 3 paired to 7. When we put 4, 2 times 4, 8. 8 plus 1, 9. There was no 9 here, so we stopped. So class, this was the relation between A and B. This was the relation between A and B. Notice, in our relation, not all members of A and B were used. Not all members of A and B were used or were paired. So therefore, A is, but all members of A, all the elements of A that are in A, is still A is the source set. I want to show you the difference between source set and domain. So 1, 2, 3, 4, 5, 6 makes up the source set. But what members of the source set were eventually paired with the second set? Only 1, 2, and 3. These 1, 2, and 3 are the domain. So the domain of relation are those members of the source set that finally make it into the relation. That means they are those members of the source set that are able to pair with the members of the target set. Those members of the source set that were able to be paired with members of the target set. So this is the source set, this is the target set. This A is the source set, B is the target set. The members of A that were able to pair with the members of B are the domain. Therefore, we can say that domain is a subset of the source set. Domain is a subset of the what? Of the source set. Please don't confuse them. Domain is a subset of the source set. Domain is a subset of the source set. I hope we are still together. Good, good, good. We have 44 people live. 44 students live. Good, good, good. Good, 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 good. I hope we are following. Yes, yes, yes. Good. Well done, class. Well done. You're still here. Well done, well done, well done. Class, this is domain for you. Let's now go to the next thing. Let's now look at range. What is range then? Range of a relation. Range of a relation. Range of relation is a set of values obtained from the domain set of values obtained from the domain who remembers this same thing we just did now when we said a equals this same set we did now. A equals 1 2 3 4 5 6 and b equals 1 2 3 4 5 6 7 8. And we said the order of the relation is b equals to 2a plus 1. We said the order of the relation is b equals 2a plus 1. When we put a into b, when we put 1, what did we have? 2 times 1 plus 1. 2 times 1 is 2. 2 plus 1 is what? 3. This 3 that's obtained is called the range, class. It's called what? Range. So that's why we say the range is a set of values obtained from the domain. Why do we say obtained from the domain? Because it was until we put 1 into this place that we got 3. So the domain was one that determined the range. So class, the range is what is a set of values that are obtained after the domain has been what? Placed. So we put 1 into this expression, we got 3. So our first range is 3. So domain and range are the set of pairs in a relation. The first pairing in every relation is known as the domain, and the second pairing in every relation is known as the what? Range. So when we put 1 into this 2a plus 1, we got 3. So our first pairing was what? 1, comma 3. 1 is the domain, 3 that we got out is the range. So you see why I said the set of values obtained from the domain, because 3 was obtained from when we put 1 into this place from the domain. We put 1 into this place and we got 3. So this 3, which is the range, was obtained from the domain. We then put 2 into this place. 2 times 2 is 4. 4 plus 1, 5. So 2 and 5. So 2 is the domain, 5 is the range. So the range is a set of values obtained from the domain. Class, just like we said when we're looking at source set and domain, we said source set. All these members are members of the source set. But only 1, 2, and 3 made it to the relation. When we put 3, what do we have? 3 times 2 times 3, 6, 6 plus 1. The remaining members did not make it to the relation. So therefore, these people that made it to the relation, they are called the domain. But everybody in this set is the source set. Everybody in this set is the source. Now, in this second set is the target set. Everybody in this set is the target. What's the name for target set? Co-domain. But the members of the target set that made it to relation is the range. Members of the target set that made it to relation is what? Range. Please take notes. So domain is the members of the source set that made it to the relation. While range, the members of the target set that made it to the what? Relation. Don't forget, domain is always the first member of the pairing, while range is the second member of the pairing. There's no better way to explain the concept of domain and range than what I just did now. Don't forget I said that because the domain was obtained from the source set, in anytime a set comes from another set, that set that came from that set is called the subset of that set, right? Subset. And remember the concept of subset and superset. Remember the concept of sub, subsets and supersets. Because the domain, members of the domain was obtained from this source. Therefore, the domain is a subset of the source set. While the range is a subset of the target set. Why? Because members of the range was obtained from the target set. Let me check if I'm not teaching myself. I hope people are still there. Please, I hope we are still there. Don't sleep. Or someone said drink Nescafe. Yes, good. Please, remember you can always rewind. You can always rewind if you don't understand. You can always rewind if you don't Understand? You can always rewind. No time to waste. Oh, good. We are here. Good. Caleb said we are here. Active like Chivita. Good, good, good. That's spirit. That's the energy. That's the energy class. Someone says, Sir, if you're relating B to A, would B be the subset? Exactly. Whoever you're relating to the other person, the first person mentioned in every relation is the source. Now that we have defined the concept of range and domain, it's time to take some examples. It's time to take some examples. Given the relation R, given the relation R equals 3, 1, minus 5, 2, 1, 5, minus 3, 2, 9, 14. Obtain the domain and range of the relation. Obtain the domain and range of the relation. Given the relation R equals 3, 1, minus 5, 2, 1, 5, minus 3, 2, 9, 14. Obtain the domain and range of the relation. Class, this is a class work. I want to see if you are following. Everybody drop your answer. Everybody on the live, drop your answer. Obtain the domain and range of that relation on the board. And with you, I'm looking at what you're going to say. List out your domain and range of the relation. Everybody, please make sure you are involved. Make sure you are involved. I want to see your answers. I want to see your answers. Obtain the domain and range of the relation. Let me see your answer. Let me see your answer. Hope you have not gone to bed, though. Where are you? Okay, Tennis Chalk said domain is 3, minus 5, 1, minus 3, and 9. Let me see your answer. Everybody, drop your answer. Everybody, even the shy people. Even the shy people, drop your answer. Some of you don't type. You don't never drop a comment here. Egolu Fabian, domain 3, minus 5, 1, minus 3, and 9. Let me see everybody's answer. Everybody drop your answer. Victor said 3, minus 5, 1, minus 3, and 9. Caleb said 1, 2, 5, 2, 14. For domain, this question is too simple. I just want to see if you are following. Please. Range. Okay, Caleb said 1, 2, 5, 2, 14. Victor Woleru said 3, minus 5, 1, minus 3, 9. Go ahead, drop your answer. Drop your answer. Christian said domain 3, minus 5, 1, minus 3, 9. Range 1, 2, 5, 2, 14. Keep dropping your answer. Keep dropping your answers. Okay, let me go and do the correction. Blessing said domain 3, minus 3, 1, minus 3, 9. Victor said 1, 2, 5, 2, 14. Tracy said 1, 2, 5, 2, 14. Is that domain or range? Class, let's go together now. Class, for domain, Dom R, this is how I'm going to write it. If it's a test they gave me in the exam, this is how you bring Dom R equals class. Pick only the first entries, 3 in each pair. 3 is the first person in this pair. Minus 5 is the first person in this pair. 1 is the first person in this pair. Minus 3 is the first person in this pair, and 9. So you're going to say 3, minus 5, 1, minus 3, and 9. This is the domain of this relation. Now, what's the range of this relation? The range of this relation are the second members of the pairing 1, 2, 5, 2, because I mentioned 2 because I don't need to mention 2 again. 14. 1, 2, 5, 14. These are the what? The range of this relation. These are the range of this relation class. These are the range of this relation. Let's proceed. Let us proceed. Next thing we want to look at now, class. Now that I'm assuming that now we understand the concept of domain and range very well. I want us to understand the concept of image and pre-image. Right now, image and pre-image. Image and pre-image. Image and pre-image. Notes. Each element in the domain is known as the pre-image. Each element in the domain is known as the pre-image. Each element in the domain is known as the pre-image. And each element in the range is known as the image. And each element in the range is known as the image. Each element in the range is known as the what? Image. Please take notes. Each element in the domain is the pre-image. Each element in the range is the what? Image. Now, right now, let's go to inverse of a relation. Inverse of a relation. Inverse of a relation. Inverse of a relation. Class. Inverse of relation. Let's give is represented with the symbol r raised to power minus 1. This is the symbol for inverse of relation. Anytime you have to find inverse of relation, it's represented with the symbol r raised to power minus 1. Class. In the inverse of relation, the domain and the range exchange positions. Class. Anytime you have to find the inverse of relation, you are going to juxtapose the what? The domain and the range. So in the inverse relation, the members of the domain now become the range, and members of the range now become the domain. Let me explain. If you have a relation R equals 1, 2, 2, 3, 4, 5. 1, 2, 2, 3, 4, 5. The inverse of this relation will now be 2, 1, 3, 2. What will you do? Just switch it. Switch. Inverse. Switch. And 5, 4. So instead of 1, 2, you have 2, 1. Instead of 2, 3, you have 3, 2. Instead of 4, 5, you have 5, 4. Class, that's the simplest question you can give in the exam. Find the inverse of the relation. Just thank your God. God has done it for you. God has done it for you. I hope we are still following. I hope I'm not teaching myself. I hope we are still following. I hope we are still following. Some people have gone to bed. Someone says, why didn't you mention the second 2 in the range? But 2 is still 2. No need to mention it 2 times. 2 is still 2. Now, the next thing we want to go to now is Cartesian products. Cartesian products. Cartesian products. Cartesian products. No, the Cartesian product of two sets A and B is denoted by the symbol AXB. So this X is representing Cartesian product. The Cartesian product between two sets A and B is denoted by the symbol AXB. AXB. The Cartesian product between two sets is denoted by the symbol AXB. The Cartesian product between two sets A and B is denoted by the symbol what? AXB. Very important. Now, if you're given two sets A and B, let's give an example. Given the set A equals 1 and 3, and B equals -7, 2, and 1. And they say obtain AXB and BXA. Obtain AXB and what? BXA. Don't forget, this topic we are teaching is covering you on Math 110 and Math 120. So it's a key topic. I did not choose this topic by mistake. I know what I am doing. Tomorrow when we come for Math 110, I'm teaching polynomials. I was maybe 1 week there and I saw the lecture was already in long division of polynomial. The lecture was already in long division of polynomial. That was topic I did that week when the network was bad. I was recording myself. I had to stop. I knew they would teach it. That was topic. I had to teach you that before you enter the lecture. I wanted to teach that topic before you enter the lecture. But that day network was so bad, unfortunately. People noticed it. Then people even calling me, sir, please, we're not, there's something wrong, but nobody's seeing you. Yes, so tomorrow will be polynomials. I knew they would teach. I saw it in day 1 before polynomial, long division. In that part, I already started it, right? I taught addition and subtraction of polynomial already. Yes, but as we're going forward, I noticed that the network was bad that day. So please, tomorrow class Math 110, polynomials. I'll break down polynomials. Now, example is, we are looking at Cartesian product between two sets. The symbol of Cartesian product is AXB. The answer to find AXB and BXA. Class, the answer for AXB and the answer for BXA are not the same. They are not the what? Same. Cartesian product is another way in which two sets can relate. That's how we're teaching Cartesian product under relations. Because the Cartesian product between A and B is only this is the only part of relation that you don't need a binding factor. This is the only part of relation that you don't need a binding factor. You just simply need to pair every member of A with every member of B. So AXB, follow me, is going to be 1 pairing with -7, 1 again pairing with 2, and 1 pairing with 1 itself. Then 3 is going to pair with every member of B as well. 3 -7, 3, 2, and 3, 1. Class, this is AXB. This is AXB. That means you're going to, how do you do AXB? For ASB, the members of A should come first for the members of B. Check in each pairing. I made sure that members of A were mentioned first before the members of B. Pick the first member of A and pair with each member of B. So one must pair with -7, first pair. One will go and pair with 2, second pair. One will go and pair with 1, third pair. 1 is done, right? So it's A that is pairing to B. When we come to BX8, it is B that will be coming to A now. So 1 pairs to -7, as I said, you can see. 1 pairs to 2, 1 pairs to 1, you can see. Now this 3 will also do its own. 3 pairs to -7, you can see 3 -7. 3 pairs to 2, 3 2, and 3 pairs to 1, 3 1. That's ASP. Let's now do BXA. For BXA, the members of B are the one coming to A now. Who is first member of B? -7. I'm going to say -7, 1, -7, 3. So -7 is done. Now 2, 1, 2, 3. Now 1, 1, 1, 3. This is BXA and this AXB. Please, I hope you still understand. We are still following. How many people are still with me? Some people will not go sleep by now. You try to. You see, people are still online. This is good. Well done, class. Well done, class. People are still online. Well done. Well done. Well done. Well done. I thought people were going to sleep. Well done. Well done. Everybody, well done. Well done. Well done. Drop a comment. Active, sir. Active. I like this set. Good. Active. Everybody, drop a comment. Active. Active. Well done, sir. Well done, class. Well done, class. Well done, class. This is good. This is good. I thought people were going to sleep. Well done. Well done. Well done. Active. Good. Good. Victor said active. Frank said well. Good. 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 Good, good. Everybody's active. This is very, very good. This is good. This is good. If you continue the exams, we will cover a lot. So yesterday, Delcy taught chemistry, did it well. Today, math. Tomorrow, math too. Then Friday, I'll come in with physics. We'll not do physics on Monday. I did physical class on Monday, but I not do online class on Monday. So I'm only doing physics this week on Friday. Tomorrow is math 110. Then Friday, I'll do physics. Well done, class. Well done, class. Well done, class. I like this energy. I like the energy. Let's do one more subtopic before we call it a day. Let's do one more subtopic before we end for today. Okay, instead of a subtopic, let me give you a class work. Let me give you a class work. Class, after this class work, it means you are done with relation, we'll then go to function. We'll now go to what? Functions. So our next Math 120 class will now be functions. Remember, the topic is relation and function. Our next Math 120 class will now touch function. But let me give a class work before we go. I know you have lectures tomorrow, so I don't want you to stay up too late. Take this last one before we go. Take this last one before we go. Given the sets, A equals X 1 minus 3 and 2. B equals -7, 1, A and -9. Find AXB. Find AXB. This will be an assignment so that in our next class, I'll know those that are following. Assignment. This is an assignment. Given the set A equals X 1 minus 3 2 and B equals -7 1 A and -9. Find what? AXB. Find AX. This will be an assignment. This will be what? An assignment for you. Please, before we go, if you're not registered for our class, don't think you're enjoying it. Very soon we'll soon stop the access. What we're just trying to show you what you're going to miss so you can see it for yourself. How we teach and break down topics. Are we together? Please, those people that pay, don't think they are not wise. Oh, me, I'm learning it free. They pay. No. Because it should just shock you that very soon I'll stop updating anybody about live class. It should just be that in our registered members group is the only way I'll drop it. You will not even know what's going on. So please, please, and please. There's a way I can do this live class to be private. If you've not registered, you will not have access. But I will make it a private thing. So even if you are subscribed to my channel, you will not know. If you've not paid me, or if I don't want you to know, you will not know. But please, we're trying to carry everybody along. We know all fingers are not equal, but at least as we're teaching you in this night like this, supporting us. You've not registered for online class. You see how we're breaking things down for you. Please message me after this class. Sir, let me join your class. Let me join your. So can add you to the other group. When exam time comes, you see the benefit of the other group. Message this number. Message this number on WhatsApp. Message this number. So we can add you. We can add you. We can add you. You can register with us. You can be paying small, small. You can start something. So let me drop this one first. I like your class and join us. Are we together? Also, if you need past exam question, is available. You can get. If you need past exam question, exam is getting closer. I check is 27th of January. Exam is first week of March. There's no time. You need to study your past exam question. You can message me to all your courses combined past question. You can have it and purchase it. You want to register for the online class? Don't joke with the online class. Don't wait till we start denying access to those that have not registered. Please do the needful. Say, okay, hold this one first. So let's register. I want to register. Add me to the register members group. So I paid for let me balance. So you can add me. Are we together? All right. Have a good night. See you tomorrow from at 1:10, same time 9 p.m. Tomorrow from at 1:10, same time 9 p.m. If you're not subscribed to our channel, hit the subscribe button before you go. If you're not subscribed to our channel, hit the subscribe button before you go. Thank you very much. Yes, Blessing said, thanks for the explanation. It's simpler than the lecturer. Good. Thank you too. Thank you too. Fabian said, thank you, sir. Thank you too. Victor, thank you. Yes, thank you. Good night, everybody. Good night, everybody. Can go ahead. Christian said, finally, yes, so go and sleep. Did I sleep already? Well done, well done, well done. Good night, good night, good night. Thank you. Someone said, easiest so far. You're the best. Thank you. Thank you. Some of those words are good. Yes. Thank you, thank you, thank you, thank you, thank you. Good night, everybody. Good night, everybody. Good night, everybody. Good night, everybody. Thank you, Caleb. Thank you, everybody. Good night.